This is a question asked in GATE 2019 Electronics and Communication Engineering paper, in which a single bit, which is likely to be 0 and 1, is sent across the additive white Gaussian noise channel AWGN, whose spectral density as N0 by 2. So the binary signaling representation of this bit, when it is 0, then it is represented by P of t, and when it is 1, then it is represented by Q of t. So it is sent across the AWGN channel with optimal receiver, which minimizes the probability of error. So in the first condition, if we choose the P of t as phi 1 of t and Q of t as minus phi 1 of t, where phi 1 of t and phi 2 of t form an orthonormal signal sets, so which will give you probability of error as P of b. So if you keep that P of t as phi 1 of t and Q of t, you changes from minus phi 1 of t to under root of e phi 2 of t. So you need to find out the value of e, so that this probability of error P of b and the probability of error from this signal state representation, that P of t as phi 1 of t and Q of t as square root of e phi 2 of t, should be equal. So you need to find out the value of e such that the probability of error from this and probability of error from this condition should be equal. So the NPTEL reference for this question is Principle of Communication System by Professor Aditya Jagannatham. So the useful data for this question is, in signal state representation, where this one is phi 1 of t and this axis says phi 2 of t. This is your signal state representation. Signal state representation, where phi 1 of t and phi 2 of t are orthonormal to each other. Orthonormal. So if you're given a bit, you can represent in phi 1 of t or phi 2 of t, or linear combination of these two, phi 1 of t or phi 2 of t. So the probability of error will be decided by the distance between these two bits, that is d min. So you need to remember that probability of error is dependent on d of min. So if you increase this d min, then probability of error will be decreased, because two bits are separated by much larger distance. So in the question, in the first condition, you have given P of t as phi 1 of t, where P of t is represented with 0, and Q of t as minus phi 1 of t, where Q of t is represented by bit 1. So in the signal state representation, this one is your phi 1 of t axis, and this one is your phi 2 of t axis. So you can mark P of t here, which is at plus 1, and you can mark minus phi 1 of t, which is at minus 1. So here is your Q of t. So the distance between these two is d min, which is equals to 2. Whatever the P of t from right hand side, same Q of t at the same distance from 0 to LHS side. So this is your first condition. In the second condition, you have given P of t as phi 1 of t, but Q of t as square root of e phi 2 of t. So in the signal state representation, you can write this one as phi 1 of t, this one as phi 2 of t. So you can mark here P of t, And here you can mark square root of E. This is the value of, this is your Q of T. So the distance between these two bits is this square plus this square from trigonometry geometry, or so this is your distance D min, which is equals to square root of E square plus 1 square. So this D min should be equal to this D min for same probability of error. For same PE, if you assume this as D min 2 and this as D min 1, then for same PE, D min of 2 should be equal to D min of 1. So you can write this one as E plus 1 equal to 2, and you can write E plus 1 equal to 4 and E equal to 3. So the correct answer for this question is option D.